Good morning. Welcome to my channel. My name is Argo Vermeer, and this is my channel, Argo Vermeer at Collectivism Kills. You can find the article that I'm going to read today on my blog, unreformingtheology.com, unreformingtheology.com. You can find the article over there in its entirety. That's where it's posted. So today I'm going to read through this article. Excuse me for a second. Sorry about this. I move for a minute. You can read the entire article there. So today I'm going to read through this article and give a few comments here and there along the way. What prompted this article I wrote, and the name of the article is Gravity, Its Proper Metaphysical Description, wherein I submit that gravity really is a metaphysical concept, and I back this up with facts and reason and logic. This isn't just something I'm pulling out of my ear. And quite a lot of thought has gone into this. But what prompted me to write this article specifically was I was listening to a debate the other day between a Catholic and a white nationalist Protestant, and being reminded why atheists are atheists, even though I obviously, if you know anything about this channel, I have my problem with atheism. But anyway, I was being reminded as to why atheists are atheists listening to this quote-unquote debate. And I'm not a white nationalist, and I'm not a Catholic. I don't subscribe to any particular Christian denomination, and I'm not a collectivist, so I wouldn't be a nationalist of any group based upon any collective identity. But anyway, in the course of this quote-unquote debate, one of them was trying to explain a point, and he was using gravity as an analogy. As gravity is this thing, and we know it's a force, and we know it works, but no man can explain it. So he goes, gravity is something that I can't really explain, and no man can explain. And I was like, well, wait a minute. That's a silly thing to say. It seems a bit odd to say, well, on the one hand, we know gravity exists. We understand it exists. It's there. It's objectively there. It objectively exists, and yet we can't really explain it. So on the one hand, we know it's there, but on the other hand, its existence is only theoretical at best, because no one can really explain what it is. And I'm like, well, you can't have your cake and eat it too. You can't claim the objective existence of a thing on one hand, and on the other hand, explain it in a way that makes its existence entirely theoretical at best. So this is not, gravity in this sense is not a thing that we can't explain. Gravity in this sense is a contradiction. Yeah, you can't explain gravity because you can't explain how 2 + 2 = 5. You can't explain a square circle. You can't explain somebody going left while they're also going right from the same observational frame of reference. You can't explain how something can be black and white at the same time, which means black but also not black at the same time. Yeah, you can't explain a contradiction. That's why you can't explain gravity, because your very fundamental understanding of gravity is this contradiction. It's defined in these contradictory existential terms. It's totally there, and we know it exists, and we know it's objectively real, but the way that we describe it, non-mathematically, makes it only purely existentially theoretical. It exists, but it doesn't. This is a contradiction. I'm like, no. The reason why you think you can't explain gravity is that no one has actually sat down and tried to explain it in rational terms. And and I'll get into this. I'm not a mathematician, and I'm not a physicist. I'm not interested in the quantification of gravity. I'm happy to leave that to the mathematicians and the physicists. What I'm interested in is the qualification. What exactly is the nature of gravity? When we see gravity, quote unquote, working, what actually are we witnessing? And that's my wheelhouse. That's something I am interested in unraveling ideas that are presented to us as verifiable fact and yet are intrinsically contradictory. And gravity is one of these things. There's many things. Once being a member of an Orthodox Protestant denomination, I see this kind of fundamental contradiction this fundamental doctrinal contradiction all over the place. We see it in government. So we see it in government, we see it in religion, we see it in science. And so what I'm interested in is looking at these ideas that are presented to us as fact, but require a cognitive dissonance to actually accept. And going, wait a minute, what's really going on here? So that's what we're going to do with gravity today. So again, I submit that gravity is it's a metaphysical concept. And I'm not a conspiracy theorist, and I'll get to this in the article. I'm not saying there's no such thing as gravity. I'm not saying it's a big lie. I'm not saying that at all. I'm merely going to explain to you what I submit you're actually looking at when you see gravity, quote unquote, working. What are you actually seeing? What is the actual nature of this thing we call gravity? So here we go. This is gravity. Its proper metaphysical description. Have you ever wondered why gravity cannot be directly observed or experienced? Have you ever wondered why only its effects are observed and experienced, but not it itself? Like space and time, we are told that gravity, qua gravity, does in fact exist. Yet these things, gravity and space and time, are always and inexorably to be inferred only. They're only indirectly known as expressions of perceivable objects. Remove these objects, and gravity and space and time are likewise removed. They become without any specific relevance, meaning, or description. That's curious. Science, which adamantly rejects anything purely metaphysical as being utterly subjective at best, nevertheless is completely certain that forces and continuums and coordinate systems, which simply cannot be qualified nor quantified, perceived or measured directly ever in the history of science, are as objectively real as you or I am, as real as the sun, stars, and moon. The only way to, quote unquote, observe gravity in and of itself is on paper or screen in a mathematical rendering. If one were to ask the greatest scientific minds in the world to show us gravity in its own independent and distinct form, they could not do so. And this is because to exist distinctly is simply not gravity's nature, meaning once you remove the thing that is said to possess gravity, say a planet, where does the gravity go? It's not there. It's gone. In fact, gravity, divorced from the object which is said to possess gravity, like in this case a planet, has no relevance. It has no meaning. It has no purpose. It can't be measured. It can't be described. It's not actually there. It is inexorably a direct function of the thing that is said to possess it. And yet, we are told it's an actual force that exists distinctly in and of itself. Or at the very least, we're told it's the curvature of space-time. See, gravity is when space and time curve. And again, without going into we're not going to get into the massive rational problems with the idea that infinite continuums like space and time can somehow be things which curve and bend and can be displaced into themselves. There's just something absolutely fundamentally irrational about the idea that this infinite continuum, this infinite coordinate system can yet somehow be displaced. None of this makes any sense, okay? I'm sure mathematically it makes perfect sense. Fine and fair enough. And in that sense, math and science are great with these kinds of things. When science is dealing with these issues on in the abstraction of the mathematics, it's completely fine. But when we're being told that space and time are things that they actually exist and they can actually bend, we start to have problems. And gravity is this force that exists in the sense of its own self. This is where we start to run into to rational inconsistencies. There's real problems with the logic in how the nature of these things is described. And and that's where I come in, I like to think. But anyway, so this is what makes gravity so special and interesting and mysterious, right? This is why science is so fascinating. It deals with the mysterious and the paradoxical. Except it's funny how contradictions become paradoxes when they are intrinsically scientific. Funny how science never extends the same courtesy to metaphysical claims. See, metaphysical contradictions are always contradictions. Metaphysics is never given the benefit of the doubt. So, yeah, science can point out the contradictions in a given religion's doctrine all day long. But when you start to point out contradictions in how science describes the nature of things, oh, it's just a paradox, you see. It's not really a contradiction. It's paradoxical. It's rational. We just don't quite understand it yet. Yeah. That's what's known as hypocrisy, boys and girls. So nevertheless, it is a contradiction to declare the objectivity of gravity's existence when such objective existence can never be verified because gravity can never, and this according to its very nature, be directly experienced or observed. Only in science can that which only exists theoretically simultaneously exist objectively. See, I don't have any problem with science when it stays in its wheelhouse. I don't have any problem with science as a methodology for measuring, calculating, and mathematically organizing what we, the observer man, how we observe our environment to act. I have no problem with science in that sense. But when science wanders beyond its boundaries and begins to LARP as essentially or implicitly metaphysical or philosophical, it becomes just this clumsy, bumbling, drunk guy. Just, kind of staggering down the alleyway and banging into walls. It makes no sense. As a methodology, as a mathematical methodology, science is great. But once science begins to describe the nature of reality and the observer, it just becomes this clumsy, bumbling, silly, drunk, crazy man. Just wanders around banging into things and breaking stuff. It becomes risible. So anyway, with that in mind, the following I submit, and again, this is not I'm not anti-science. I'm anti particular schools of thought thinking that they can become everything else. In the same way that I would have a problem with a carpenter who insists that he can do my taxes because he's a carpenter. It's the same kind of problem I have with the scientist who decides, well, because I'm a scientist and I have an IQ of 160 and I'm so smart that I can be the world's greatest metaphysician. And I can do philosophy now, and I can explain the nature of things, and I can even explain the nature of consciousness. This is the problem. It's the exact same thing as when the carpenter decides he's going to be an accountant because somehow being a carpenter necessarily means he's an awesome accountant. It doesn't make any sense. So this is the only problem I have with science, is it's LARPing these days, particularly in the West, as philosophy. And it's very, very bad at it. But science itself is wonderful in its own wheelhouse, in its own place. It's great, and it's admirable, and it's hard, and I admire people that are good at it. So, okay. With that in mind, the following I submit represents a description of gravity that both defines and explains it in a way which, unlike it is with science, is not intrinsically contradictory and puts it in its proper metaphysical and conceptual place, which is where it has actually existed, in fact, all along. And at this point, I will say, if you are, and this is not to be insulting, and this is not to make me sound like a pretentious jerk, but if you're not interested in, if you don't like to think, if you're not interested in stretching your brain, if you're not interested in complex thinking, if you're uncomfortable with relatively technical language, then this might not be something that this video might not be something for you. It doesn't mean that you're dumb or stupid or can't understand or what. I'm just saying that if you're not interested in complex ideas, if you're not interested in thinking through things, if you're not interested in considering different ideas, and if you have a problem with technical language, then this is not going to be something that you'll enjoy. So That's just a fair warning. Okay. Now, to be clear, I'm not suggesting that gravity is a simple thing to quantify or that it shouldn't be quantified. Nor am I suggesting that this is what I will do here. The quantification of gravity I'm happy to leave to the mathematicians and physicists. In this article, it is my intention to qualify the nature of gravity in rational terms without appealing to contradiction or paradox. So, before I get to the body of my article, there are two issues that need to be addressed first. Number one, I should not be confused with a conspiracy theorist. I'm not, for example, like a flat earther, that kind of thing. I believe that the earth is round. I believe that gravity is a thing. As previously stated in this article, I'm perfectly fine with how science quantifies gravity. I accept the math. I don't believe that anyone or any institution is purposefully engaging in some kind of gravity deception. I'm not a gravity denier. What I don't accept is simply how science qualifies gravity. That is, how it describes its nature. Because that's not science's job. Okay? And number two, I think there's a fair number of people out there who think that gravity is real because they think they can feel it. Like, I believe that there's, and I don't know the exact numbers, but I believe that the percentage of people who believe in gravity because they think they can feel gravity is fairly high. And I want to get this clear right now. The evidence of gravity is not, like, people go argue, you're crazy. Obviously there's gravity, you can feel it. If it didn't exist, you wouldn't be able to feel it. No, gravity is not something that you can feel. You can't feel gravity. The fact of the matter is that, well, I put it this way. It's like, what would it feel like to be pulled on by gravity in an infinite vacuum? Say, there's no atmosphere, there's nothing beneath your feet that you're going to run into, there's nothing to offer resistance beneath your body. You're just being pulled on by gravity in a vacuum. What would that feel like? Well, we actually know what that feels like, because that's what's happening with astronauts when they orbit the Earth. They're in a perpetual free fall. And what it feels like is weightlessness. In fact, it doesn't feel like anything at all. In fact, relative to gravity, it feels like no gravity. Weightlessness feels like nothing is pulling on you because you feel weightless. Now, I understand that you could say, I mean, you could make the argument, well, the mathematics say that, it's the linear velocity versus the free fall velocity cancels out the gravity, so it feels like weightlessness. And okay, fine, fair enough. I don't know the math. I'm skeptical, but if they're insisting that the reason why you feel weightless is because it's like this intersection of like linear velocity around the Earth plus the falling due to gravity, okay, fine, fair enough. But there's no real linear velocity when people go up in planes and then the plane begins to drop suddenly and there's this feeling of weightless for a few seconds. There's no linear velocity. That's in the sense that there's a massive linear velocity for somebody in orbit going around the Earth. Relative to that, the velocity you'd be feeling in a plane is infinitesimal. So it would be technically, there would be not enough linear movement to cancel out the pull of gravity. So if you're on an airplane and the airplane drops suddenly, like several thousand feet, you don't feel like anything's pulling on you. You feel weightless. So the point is that absent any resistance, any actual physical resistance to your body, and it's just the pull of gravity, quote unquote, you're experiencing, the feeling is weightlessness, which is the absence of gravity. It feels like there's no such thing as gravity. In fact, it feels exactly like it would feel out in the middle in the vacuum of space with no gravity around whatsoever. So, A, no, you can't feel gravity. And number two, I don't even know if this is number two, but anyway, I went to Google and I wrote this down. I typed this in. I said, how do you feel gravity? And this is what Google's AI gave me. And this is exactly what I expected it to give me, because I had been thinking about that. I was like, well, how do you like, okay, so you can feel gravity pulling on you. Where exactly is it pulling on you? Pulling on your legs, pulling on your head, pulling on your arms. I was like, no, it would have to pull on all of your body all at once, and not just all of your body in terms of your, it would have to pull on all of your atoms and molecules and particles at the same time, in which case you wouldn't be able to detect necessarily where gravity was pulling, because it would be pulling on literally every single part of your body down to the very particle at the same time. You wouldn't be able to consciously pinpoint where it was actually pulling from, and therefore you wouldn't feel it pull anywhere, because in order to feel something pull on you, you have to be able to localize the feeling. This was what was going through my head. So I typed into Google. I said, well, what does the pull of gravity feel like? And this is what Google says. And Google AI is absolutely right. Google says, because gravity acts on every part of your body equally, you don't experience a sensation of being pulled down unless there is a counterforce like the ground pushing back up on you. So yeah, in other words, no. Without going into the detail as to why a force which acts on every part of your body equally can't be felt, which I understand why this is, but it's not really relevant right here. The point being is that no, you can't feel gravity. What you feel is gravity only, as I said before, like I said, you can only experience and observe gravity indirectly by some kind of, like Google says, a counterforce, like the weight of the chair pushing up on my butt as I'm sitting in it. That's the only way you can feel the wind resistance that a skydiver might feel by, rushing through the atmosphere. You can't feel gravity directly. You can't. You can only feel it or experience it utterly indirectly, because that's its nature. Its nature is that it can never be directly observed, and therein lies the intrinsic contradiction when we're being told it's a thing which actually exists. By its nature, it can only ever exist theoretically, because you can only ever observe it and experience it indirectly. So, having said that, I submit that gravity is not actually a force at all. It's not really a thing. There is no such thing as gravity qua gravity, but gravity, rather, is the perception of a specific kind of relative relationship that we observe between and experience between objects. So, what gravity is then is not gravity qua gravity at all. Gravity is not actually there in any literal sense of the word. Rather, gravity is a concept that the observer, man, uses to describe a specific relative relationship he perceives between objects in space. And by perception, I mean you can experience this relative relationship, as I said before, in terms of feeling a counterforce, the friction of the air rushing past the body of a skydiver, that kind of thing. But gravity is not there in any literal sense of the word. It's a concept. Gravity is a concept that the observer man uses to describe a specific kind of relative relationship he perceives between objects in space. And more specifically, gravity relates to the root existence of any given object. Now, here's where you're going to have to put your thinking caps on, and you're going to have to hang on and stay with me. So gravity, I propose, relates to the intrinsic act of existing. It's like a fourth dimensional movement, the act of existence. I would qualify it as a kind of a fourth dimensional movement, one could say, and manifest as a constant rate of what I call existential acceleration. But we're going to get to that in a bit. So gravity relates to the act of existing, which I describe as a fourth dimensional movement, manifest at a constant rate of what I call, quote unquote, existential acceleration. Now, I know, here's where I start talking crazy. Here's where the craziness, here's where the psychotic ideas come in. But despite what you might be thinking, there's nothing particularly silly or clumsy about this assertion. It sounds crazy, but it's not really. And I submit that gravity in this sense becomes almost obvious once we make a single and relatively minor cognitive adjustment to how we think about the nature of existence. So once made, the relative relationship we call gravity becomes clear, and further, I submit, is consistent with all current scientific explications of how gravity is observed to behave. So here's this little minor cognitive adjustment that we can make in how we consider the nature of existence. Let us consider that the nature of existence is not passive, but active. that there's no such thing as an object at rest fundamentally, and thus existence itself represents an inexorable constant state of activity, and that this active existence can be described as an object's, quote, constant rate of existential acceleration along what I have called its path of existence, or POE. I'll just refer to path of existence as POE. And this is indeed what I submit, that gravity is how the observer, man, conceptualizes the active existence of objects. When we understand that existence is not passive but active, and thus represents a peculiar fourth-dimensional movement of its own, then the mystery and the contradictory nature of gravity as it is currently described by science fades and is replaced with a simple metaphysical equation, so to speak. Active existence equals a constant rate of fourth-dimensional existential acceleration along a path of existence. Now, I know you have a lot of questions, and the problem is when you're dealing with complex ideas, the first time you hear something that doesn't quite sound right and you start to have questions, you're going to want to stop and ask questions. You have to let me get through the article. I've already predicted the questions. I've already predicted what people are going to think and say at this point. I have addressed them, or at least what I think is all of them, if at the very least most of them, if not all of them. So I'm begging you to, before you stop the video and go, she's full of crap, this doesn't work, just hear me out. Hear me out. All right, so active existence equals a constant rate of active existence translates into a fourth-dimensional constant rate of acceleration along what I have called a path of existence. Okay, thus when we consider the pull of gravity, which you can't feel any pull, thus when we consider the pull of gravity of a more massive object on a less massive object, like for example a planet quote-unquote pulling on a meteor, for example, what is the actual nature of this relationship according to my thesis? As the meteor wanders too close to the planet, it's not actually being pulled in by the planet's gravitational quote-unquote force. This is how it will appear to an observer, but this is an optical illusion. What's really happening is that the meteor has wandered into the planet's POE, path of existence. If the meteor is not moving at a sufficient enough velocity to get beyond the planet's POE before intersection, it will eventually collide with the planet's surface or burn up in the atmosphere. It isn't that the meteor is being pulled in by the planet, but rather the planet, in accelerating along its own path of existence, has in essence, quote unquote, run into the meteor. Now, to an outside observer, like you're in a spacecraft and you're some distance away and you're observing this from some distance in your little spacecraft. To an outside observer, this collision looks as though the meteor is being pulled in by the planet. He sees it curve away from its linear trajectory and down towards the planet. But this is an optical illusion. Okay, now the question here is why the illusion? And the illusion is because of this. The existential frame of reference is the same for all things, including the observer. So it must be understood that all things equally exist. This is axiomatic. I do not exist to a greater or lesser degree than you do. The ball doesn't exist to a greater or lesser degree than the bicycle does. Thus, in the above scenario, the observer, the planet, and the meteor are all equally accelerating at the same constant rate along their own respective paths of existence as a function of existing. This is why the observer perceives the act of the smaller meteor curving into the planet, and not the planet expanding out, quote unquote, to collide with it. Possessing the same existential frame of reference as the meteor and the planet means that the observer perceives the gravitational relationship in parabolas, in curves, in bending, and forces, quote unquote, which, quote unquote, pull. The existential frame of reference is the same for all objects involved. Thus, gravity will not be perceived linear. Again, it will be perceived as a parabolic relationship in curves. That has to do with the fact that the existential frame of reference is equal. All three things in the scenario are under the same exact constant rate of existential acceleration because they all exist to equal degrees. The plurality of existence means that everything which exists in equal measure, obviously. So to put it another way, let's say that in the above scenario, or for example, here's a little thought experiment. Say the planet, the meteor, and the observer are all just sitting still in space at enough distance from one another that gravity is not a factor. None are moving in any linear fashion. They're just sitting there in space. None are moving in any direction in any velocity. They are bodies at rest, so to speak. What movement will the observer then perceive? What movement is the observer going to see amongst all three of these things? Well, the answer is none. Existential movement, the constant acceleration of an object along its path of existence, it cannot be directly perceived by the observer, since the rate of existential acceleration is the same for all things which exist, including the observer. Thus, gravity, a sort of fourth dimensional existential acceleration at a constant rate, quote unquote, shall be perceived when a less massive object travels in space relative to a more massive one at a close enough distance to have wandered into the massive object's path of existence. And the observer will observe that relationship parabolically, or in parabolas, as the smaller object being curved into the larger planet rather than the larger planet expanding out, so to speak. Gravity shall also be perceived, of course, by the fact that less massive objects can rest upon a more massive object's surface. The reason why I'm planted firmly in my easy chair right now is because of gravity. Yet it isn't that I'm being pulled down by some unseen force. Rather, I'm experiencing the effects of a significantly more massive object, in this case Earth's, existential acceleration. I am under the existential acceleration of Earth due to the difference in mass. Now, here's another question that I'm sure has come to your mind, to any of my astute listeners. If all objects exist to an equal degree, and therefore the constant rate of existential acceleration is likewise equal, why do objects possess greater or lesser degrees of gravitational force as a function of their mass? Why is gravity stronger on, say, Jupiter than it is on Earth if both Earth and Jupiter existentially accelerate at the same rate? You might be thinking, well, if Earth and Jupiter exist to the same degree and have the same constant rate of existential acceleration, why does Jupiter have stronger gravity? Why is the force of gravity stronger on Jupiter? Sorry, hold on for a second. Sorry about this. Okay, so I know what you're thinking. Okay, now, sorry about that pause there. I had something just happened. Sorry. Okay, I'm good now. All right, so discrepancies of perceived gravitational force have to do with the size, we could say, of the path of existence. So, yes, I concur. Gravity is stronger on Jupiter. Yes, it is. This is a fact. I acknowledge this fact. Discrepancies of perceived gravitational force have to do with the size, we could say, of the path of existence. This is why. It stands to reason that the more mass an object possesses, the greater the size of that object's path of existence. The more mass an object possesses, the wider and extending further out is their path of existence. Thus, the greater gravitational force, quote unquote, the greater the gravitational force which will be perceived by the observer. So, the more mass an object has, the wider and longer is its path of existence. And this is why these more massive objects are perceived to have greater gravitational force. So the reason, for example, that Jupiter's gravity is more forceful, quote unquote, than Earth's is because Jupiter is much more massive and thus possesses a much larger path of existence. So hang in here, stay with me. Jupiter's path of existence therefore extends much further out into space than Earth's. And this is a fact. Jupiter's gravitational force does extend further out into space than Earth's does. This is a scientific fact. So the reason that objects which appear to be drawn to Jupiter by its gravity do so at a greater overall rate of acceleration is because they are in effect under acceleration for a longer duration before intersection than they would be relative to Earth. They have a longer time to accelerate because the path of existence is longer. So they are under acceleration for a longer period of time. So by the time they intersect with Jupiter, they're going faster. which translates into more force, you see? So the greater an object's mass, okay, so the general rate of existential acceleration is a constant that is non-relative amongst all objects which exist. However, there are relative discrepancies which are a function of the size of an object's path of existence. The greater an object's mass, the larger the path of existence, the greater the time under acceleration, which translates into larger objects possessing a relatively greater gravitational force. So, for example, if you have a wall and you place a truck a mile out from the wall, and the truck accelerates at a constant rate to the wall, by the time it hits the wall, it's a mile away, it's going to do so at X amount of force. So, you have a wall, a truck is a mile away. The truck accelerates at a constant rate of speed to the wall. When it hits the wall, it will do so at a given amount of force. If you take the same truck and the same wall, but now they're 2 miles apart, the truck will accelerate at the same rate, but by the time it hits the wall that's 2 miles away from it instead of 1, it's going to do so at a greater degree of force because it is under acceleration for a longer duration of time. So the fact that a more massive object has a path of existence that extends wider means that any object caught in the path of existence is going to be under acceleration for longer periods of time, which translates into a greater amount of force by the time they intersect with that more massive object. Now, again, it's not that they're being pulled in, it's that the massive object is existentially accelerating out, but it has more time to do so because its path of existence is longer. So I hope that makes sense. Again, this is not something that's easily explained. Like, this is something that does take a little bit of thinking power, okay? So now remember this, the force, or the quote-unquote pull of gravity, is an illusion. The smaller object isn't actually accelerating in towards the larger. Rather, a more proper description of what is actually happening is that the larger is accelerating, quote-unquote, sort of out towards the smaller, out towards in the fourth dimensional sense, because it's accelerating as a function of its existence. So it's not accelerating linearly, okay? I know it's getting a bit abstruse now, so I'm going to slow down and explain this in more careful detail. It's important to understand that existence as movement or acceleration is a rather difficult thing to conceptualize. Again, it represents a kind of fourth dimensional movement, and thus it must be conceptualized in a very unique way. So naturally, being fourth dimensional, existential acceleration, quote unquote, is not linear. So it's hard to render it in three-dimensional space. It's hard to give you practical analogies in 3 dimensions. But like, for example, in the case of the truck accelerating to the wall, the math is still the same. The time of acceleration is still longer. The time under acceleration is still longer if the wall and the truck are 2 miles apart as opposed to 1. But technically, according to my thesis here, it's more like you observe the truck accelerating towards the wall, but what's really happening is that the wall is accelerating towards the truck. But it's doing so in a fourth dimensional sense, which means that to an outside observer, it will look like the truck is accelerating towards the wall. So that's kind of the best that you can really do when trying to render a fourth dimensional movement in sort of 3-dimensional space. Is you kind of have to do it in sort of a little bit contradictory analogies, so to speak. Okay, at any rate, so here is the basic equation explaining discrepancies in relative gravitational force, according to my description of gravity. More mass equals a larger path of existence equals more distance for a more massive object to, quote-unquote, existentially accelerate towards a less massive object caught in its path of existence. This equals greater relative gravitational force. Again, it isn't that the more massive object exerts greater gravitational, quote-unquote, pull, and it isn't that more massive objects existentially accelerate to a greater degree than a less massive object, or at a greater constant rate. It's that more massive objects have paths of existence which are longer and larger, and thus extend further out into space, which means that there's more time for the more massive object to, quote-unquote, existentially accelerate towards any object caught in its path of existence. Gravitational intensity is a function of time in the path of existence. Further evidence to support my thesis. Now, this is something you will understand. Well, I hope you understand everything. I don't mean to insult your intelligence. But this is good evidence. I find this to be strong evidence to support my thesis. And that's the fact that objects under the influence of gravity, say the Earth's gravity, they all fall at the same rate. It doesn't matter their size or mass. So, for example, when accounting for mitigating factors like wind resistance and other things, a penny, if you drop a penny in a bus from the same height, they hit the ground at the same time. They fall at the exact same rate of acceleration. A feather will fall at the same rate of acceleration as a bowling ball. So if you were to somehow remove Earth's atmosphere and you were to drop a feather and a bowling ball from the same height, they hit the ground at the same time. It doesn't matter the size or weight or difference in mass between the objects being dropped. They all hit the ground at the same time. Gravity acts upon them equally. They fall at the same rate of acceleration. So this, if you think of gravity in the terms that I have described it, this makes perfect sense. Because an object, quote unquote, existentially accelerating is going to accelerate towards, or any object accelerating, any object which is accelerating towards something it doesn't matter what's in front of it. So I say it this way: an object existentially accelerating will necessarily accelerate towards various objects in its path of existence at the exact same rate. There's no intrinsic properties of objects caught in the path of existence which change the degree to which they are being accelerated towards by the more massive object. So, for example, in the same way that a truck is going to accelerate towards it, if you have a truck and it's accelerating down the road and you put a wall and a tree in front of it, the truck it's not going to accelerate to the wall slower than it will accelerate to the tree. It's not going to accelerate to the penny at a different rate of acceleration than it's going to accelerate to a house. The truck doesn't care what's in front of it. Whatever's in front of it doesn't change the rate of its acceleration. It's going to hit them at the exact same time. It doesn't matter how big or small they are. Whatever's in front of the truck, the size, weight, and mass difference is irrelevant. It accelerates towards both of them at the exact same rate, and it hits them at the same time. So again, in my thesis, if gravity represents this fourth dimensional rate of acceleration, and so in a sense you could say it's accelerating, quote unquote, out towards whatever's caught in its path of existence, it's going to hit them. It's going to hit whatever's there at the same rate of acceleration. It's not going to. There's no intrinsic difference in whatever the object is accelerating out towards that's going to make it accelerate at a different rate to one versus the other, if that makes sense. Okay, I think I've beat that to death, so I think you get that. So, so I submit that the difference in mass is a difference in path of existence. So the greater the mass, the longer and wider the path of existence, the greater the object has to accelerate along its path of existence towards whatever is caught in it. And therefore, that accounts for the discrepancy in force. Okay. So, as I refer to gravity in this article as the manifestation of an object accelerating at a constant rate along its path of existence. I need coffee here. A question might arise is, why is the movement of existence acceleration and not velocity? Why a constant rate of acceleration and not a constant rate of speed? Well, the answer is rather simple, I think, but it's not perhaps intuitive. So why is acceleration? Why is the movement of existence acceleration? Why not just a constant velocity? Well, I put it this way. In simple terms, or the simplest terms I can put it, speed or velocity is fundamentally passive, while acceleration is fundamentally active. So in a vacuum, an object traveling at a constant speed is not itself. In a vacuum, an object to travel at a constant speed doesn't need itself to really be doing anything or having anything done to it. Meaning an object traveling at a constant velocity in a vacuum can be passive, perfectly passive. It doesn't need to exert any force, and it doesn't need to have any force exerted on it. It doesn't need to be active. It need not do anything nor have anything done to it to maintain that constant velocity. So this is not so for an object in a vacuum, which is moving at a constant rate of acceleration. You see, for an object to maintain a constant rate of acceleration, that is, constant increase in velocity over time, it has to be active. It must be doing something in order to constantly be motivated to greater and greater rates of speed, to greater and greater increments of velocity, you see? So it has to be actively doing something in order to constantly accelerate. It doesn't matter if it's doing it itself or it's receiving, it has to be active. It has to be an active participant in the acceleration. It has to be either doing something or receiving some kind of activity. It has to be active, or it has to be actively receiving some kind of an action in order to maintain the constant rate of acceleration. In metaphysical terms, it's very simple. Velocity in a vacuum is a passive state of existence. Acceleration in a vacuum is an active state of existence. And of course, my whole thesis rests on the idea that existence is active. And it is, because it has to be. And I will explain why existence must be active. Existence cannot exist if it's not active. In other words, active existence is a redundancy. There is either active existence or there's no such thing as existence. If something exists, it must be doing so actively. So the point here is that an object under a constant rate of acceleration must be an active participant in the movement. An object which is merely maintaining a constant velocity need not be participating in anything at all. It can be completely passive and yet still be moving. Not so with acceleration. Thus, if existence is active and represents movement, the movement of existence, or the movement of existing, I might say, then it must be active movement. It must be movement where the object participation is always required. Thus, the movement must be a sort of existential acceleration and not merely existential velocity. So further, it could be argued that for a single object in a vacuum, a mere constant rate of speed does not necessarily represent fundamental change over time, whereas acceleration does. Perhaps better said, acceleration represents constant change over space and time, where velocity is only change over space but not time. Therefore, it's only partially existing. You see, it's only existing in space but not time. This doesn't make any sense. If something exists, it must exist in space and time. And so velocity represents only change over space, but not in time, where acceleration represents change in space and time. Space and time are corollary. That's why mathematicians and physicists refer to it as space-time when they're talking about the coordinate system, not just space or time. They're different, but they're corollary. And so you don't really get one without the other. Therefore, well, anyway, you get it. So now the obvious question begged is, why must existence be active? Why can't existence be passive? Well, this boils down to simple logic. And it goes something like this. According to what exactly do things exist? Well, the answer is according to their ability. In other words, things exist because they are able to exist. And ability, absent action, is irrelevant. In other words, ability and action are corollary. You don't get one without the other. So you can't have ability absent action. Ability absent action is irrelevant. If you have ability, there must be action. In other words, ability implies doing, action. Ability without a corollary action is ability which is irrelevant. That is ability which might as well be unable. It is the function. So ability absent the corollary action is the functional equivalent of inability. Ability, thus necessarily, implies action. Ability is active. Inability is passive. Therefore, to say that an object's existence is passive is ultimately to say that the object is unable to exist. If we say an object exists, it exists according to what? Its ability. Inability requires action. In this case, what action? Existing. Okay? So, to say that an object only passively exists is to say that it in essence or fundamentally does not possess the ability to exist. So, passive existence represents an inability to exist. This is a contradiction. Therefore, if an object exists, then it exists because it's able to exist, and therefore its existence must be active. In short, passive existence is existence which is unable to do anything including exist, okay? So that's just, I'd like to think, simple logic. If something is existing, it exists according to its ability. Ability requires action. And in this case, the action is existence. So existence implies the ability to exist, which means that the existence must be active. It can't be passive. Passive existence is the functional equivalent of not actually existing, okay? So existence must be active, and that's why I qualify gravity as the active existence. And as I said before, it represents acceleration, a constant rate of existential acceleration, not merely velocity, because it has to occur in both space and time, and blah, blah, blah. So I already went through that. Okay, so this concludes what I assert is the proper metaphysical description of gravity. I submit that it is the most accurate description of what gravity is actually doing. It's hard to picture in three-dimensional space, but I believe that this represents to date the most accurate description of the nature of gravity, meaning that gravity is how the observer perceives any given object's active existence. It is the acceleration at a constant rate of an object along its path of existence. The more mass an object possesses, the larger its path of existence, which accounts for the perception of a stronger gravitational quote-unquote pull. A larger path of existence equals existential acceleration, quote-unquote, over more time, equals greater gravitational force relative to objects with less mass caught in its path of existence. So, anyway. Larger path of existence equals existential acceleration over more time equals greater gravitational force relative to an object with less mass and thus possesses a smaller path of existence. This is just a summary. Okay, and you can, again, feel free to read this article on unreformingtheology.com. It might clear things up if you actually just read the article without me interjecting. Maybe I'm doing myself a disservice by commenting on my own article. I don't know. Hopefully it's clearing something up, but I know I'm not the greatest speaker in the world. So, all right. But before I end this article, there is a couple of things that I need to address, and because I'm sure that they're already on the minds of people who are relatively familiar or have thought about gravity or researched it much. So first, I have to address the issue of gravitational lensing, quote unquote. So for those of you who don't know what gravitational lensing is, it's actually really cool. It's a thing. I'm not denying it. It exists. You can see it. You can actually see it. It's wild. There's pictures of gravitational lensing. It's the phenomenon where light can be observed to bend around massive objects in space. You can see a massive object in space, and you can see the light sort of refracting around it. It's wild. It's really cool. Gravitational lensing, this is where it gets not so cool. This is where science starts to LARP as like explaining the nature of things. And this is where it starts to get all clumsy and it starts to drink too much. This is where science starts to drink and gets drunk and begins to stumble down the alleyway. Because here, gravitational lensing is presented as evidence for the objective existence of and curvature of space-time. So space-time, by definition, an infinite continuum can somehow bend and curve. And the evidence, we're told, is gravitational lensing. No, that's not what happened. That's happening. Yes, gravitational lensing is a thing. You can see it. You can see light bending around massive objects in space. Yes, but it's not because of this contradiction where some infinite mathematical coordinate system can somehow objectively exist. This purely abstract, theoretical mathematical coordinate system somehow actually exists objectively and can bend into itself. That's not why we see gravitational lensing. And this is the problem. The science, rather than examining the logic of what it says, just like goes with it. It's like, oh man, science is so awesome. Look, we can prove that space-time actually exists because we can see light bend. And instead of going, that doesn't make any sense, they'll just go with it. Instead of going, well, that can't possibly be what's happening. Space-time can't curve. It can't exist in any actual sense. So something else must be going on. Obviously, the light's bending. We can see it, but we know it can't be the curvature of space-time because that doesn't make any sense. That's a contradiction. You can't have an infinite coordinate system bending into itself. There's nowhere for it to go. It's infinite. Infinity can't be displaced into infinity. So, okay, so this is what gravitational lensing is, I submit. Okay, gravitational lensing is simply the observer perceiving the effect of light being emitted in a steady stream of protons and, due to its great speed, perpetually outrunning or moving past the path of existence of a given massive object. Light appears to bend as it moves away from that massive object's path of existence. So I was trying to think, how can I relay this in three-dimensional terms? Again, it's not really easy to represent a fourth-dimensional movement like the acceleration of existence in three-dimensional space, but here's my attempt. So think of it this way. There's a truck accelerating down a road en route to collide with an endless train that's running perpendicularly across its path. This train is endless, doesn't have an end. The train just goes on, and it's running across the road. And this truck is barreling down the road, accelerating towards it, en route to collide with it. Now, here's where it gets tricky. Think of it this way, no matter how fast the truck goes, it can never actually collide with the train. Even though, as I said, the train is endless. And even though the train is running perpendicularly across the truck's path. The reason the truck cannot hit the train is because the train is always moving fast enough to outrun the truck. So just as the truck arrives at the train, it is perpetually not there relative to the truck. But it's an endless train. So you got to really, it bends your brain a little bit. The train, because it's moving so fast, even though it's endless, is never struck by the truck. It's moving too fast for the truck to hit it, and therefore, functionally speaking, the train isn't there once the truck arrives where the train is crossing its path in the road. It can never strike the endless train because the train is moving too fast, and the train is never there. Every single car always manages to get out of the way before the truck can hit it. So how would this look like in three-dimensional space? Because obviously this represents a kind of a contradiction, right? So we have to think of it in three-dimensional space for our minds to understand it. And I say this. It would look like, I submit, that the train is persistently bending or bowing away from the truck near the point of impact. In other words, each car of the train just before impact is able to slip past the nose of the truck and continue traveling in the direction it was, while the truck speeds on by. So as an observer, you would notice that the train continually bows outward as the truck bows down the road, and the train would appear to be bending around the nose of the truck. Okay? So this is what I submit is happening when we observe gravitational lensing. Light is always moving too fast for the object, the massive object, which is existentially accelerating along its path of existence, to actually hit the light. The light is always perpetually outrunning the existential acceleration of the massive object. And it looks to the third-party observer as the light bending around the object. Gravitational lensing. So that is what I suggest is happening. And I believe it's not only a rational explanation, but it's certainly more rational than saying that an infinite and only purely theoretical coordinate system like space-time actually exists and can bend into itself. As crazy as my thesis might sound, it's not crazier than that, not by a long shot. Okay. And secondly, I want to touch upon the expanding universe. So here I think, too, my description of gravity can help explain this phenomenon without having to resort to some mysterious and ultimately self-contradictory notion like dark energy. Yeah, dark energy is another one of these things, which is like, again, it's where science does not extend the same courtesy to metaphysics as it does to itself. If Christianity had a thing like dark energy, atheists like Christopher Hitchens and Richard Dawkins would be all over that shit. That doesn't make any freaking sense. It's this magical mystery spaghetti monster in the sky that we can't really observe, and it's only theoretical, but somehow it still exists and it's doing something. But because dark energy is a scientific concept, well, it's paradoxical at best. I mean, we know it's there. It's mysterious dark energy. It's there and it's doing something. Dark energy is like the flying spaghetti monster of science. But again, you have to understand that when science becomes philosophy, it just becomes an ideology, and therefore it becomes hypocritical. This is why atheism is this in. Anyway, I don't want to go into the atheist things. It's all ideology, man. Everybody's science, when it becomes philosophy, it's as mystical as any other religion, man. It just is. But let's talk about the expanding universe without appealing to things like dark energy. Let's not appeal to the flying spaghetti monster of science. So objects like galaxies, so massive objects like galaxies, when they're viewed from a great difference, present as a single thing. They're this giant supermassive thing way out there in space. So objects like galaxies, which are separated by sufficient amounts of space, will, like all objects which accelerate along their path of existence. Galaxies, which are separated by sufficient amounts of space, will, like all objects, accelerate along their paths of existence. However, due to the extreme distances between these objects, there's no gravity. See, the reason why there's no gravity observed between these galaxies way out there in the universe is because none of them are close enough to be within the path of existence of the other galaxy. So they're just sitting out there in space. Again, I'm not an expert on this. This is my theory on this, okay? But there's no gravity observed between these galaxies way out there because the objects are separated by sufficient amounts of space to the point where these galaxies never cross each other's paths of existence. So gravity, in the way I've described it, doesn't have any bearing on how these objects are observed from our frame of reference. So if we're not observing any gravity relative to these giant massive things called galaxies way out there, because they're not close enough to wander into each other's paths of existence, then how will they be observed? Will they be observed to be simply merely stationary? They're just going to sit there for an infinite amount of time? Well, no, because existence is active. Existence is active. It's movement. So I would suspect that you wouldn't necessarily see objects just sitting, massive objects like a galaxy just sitting stationary in space for an infinite amount of time because they're doing something. They're existing. So, okay, well, if they're not just going to be sitting there at rest, they're going to be doing something. Well, are they going to eventually be drawn closer together? Will the universe contract? Well, no, because we would observe objects being close together because of gravity. So it would be objects wandering past each other's paths of existence, which creates this effect we call gravity. So it's this wandering past the path of existence which creates this sort of contraction where objects are observed to be drawn to each other. But that's not a thing out there when there's that much space separating the galaxy. So they're not going to be observed to be pulling together because gravity's not working. So there's only one option left, and that's that they will observe to be, quote unquote, pulling away from each other, expanding away from each other. They're going to continue to accelerate along their individual paths of existence at a constant rate. And of course, it's acceleration, so the rate of expansion will increase over time because existence is acceleration. It's not a constant velocity. So you're going to see the universe expanding over time. And the expansion will increase in acceleration because existence is acceleration, which means it goes faster and faster over time, right? So that's my theory on how my thesis fits into the idea of the expanding universe. So, all right, I'm going to be done. I'm sure I have stretched your brains, and maybe painfully so. For those of you that have come this far, I thank you to anyone who has bothered to read this or listen to this. Your time and attention are more appreciated than you can possibly know. So, to wrap up, allow me, after all this time and energy and effort I put into developing this thesis and writing it out and then explaining it to you all lovely people, indulge me with a little bit of what might sound like pretentious therapeutic cope. Allow me a bit of what might sound like arrogant psychological cope. I'm self-aware. I fully expect this thesis to be disregarded out of hand as errant nonsense by the vast majority of those who even bother with it. And that number will almost certainly be zero. Or not zero, but close to zero. C'est la vie. It is what it is. And I submit that, like virtually all creative ideas that truly offer something new, productive, and of valid substance, their fresh take is usually rejected as madness at first. Oh well, as I said, such is life. Nevertheless, I submit that I shall certainly be validated in the... And that's the end of the article. End. Okay, so that's all I have for you. I hope this was interesting. I hope you forgive any background noise. I hope there wasn't too much background noise, but sometimes I get moving in the chair and you might hear some scratching or rubbing against the microphone. I do apologize, but as I said before, this is a low-tech operation. You can read the article on unreformingtheology.com. That's unreformingtheology.com. Sorry for my voice. I'm a little congested. It's super cold and dry here where I am. But yeah, having said that, I appreciate you listening. And yeah, this is Argo Vermeer saying until I talk at you next time, have a good one. Take care. Bye.